Okay. Um, Good day, students. Nice to meet you. Today we are looking at oxides. Oxides are very useful in chemistry. In fact, the water you take is an oxide. It's an oxide of hydrogen. So, and you know that we can't really do without water. Water is an oxide. So, oxide is a combination of an element and oxygen. For example, calcium plus oxygen will give you calcium oxide, as you can see on this PPT. So when magnesium, for example, reacts with oxygen, that will give you magnesium oxide. And when sulfur reacts with oxygen, that will give you sulfur dioxide. Yeah. Um, so we have different types of oxides. So many oxides. So that's why it is very important for us to talk about classification of oxides. Yeah, we classify oxides as follows. So we have amphoteric. So anytime you hear the word amphoteric in chemistry, it means something that can act as an acid and a base at the same time, or something that can react with an acid and it will also react with a base. So remember what I said, amphoteric means something that can react with an acid or something that can act as an acid and it can also act as a base. So we have amphoteric oxides, we have basic oxides, we have acidic oxides, and we have neutral oxides. So these are the four types of oxides that we have. Okay, like remember what I said, we have a lot of oxides, so we need to classify them. We need to classify them based on their acid-base nature. Acid-base nature. Some are acidic, for example, SO2. SO2 is very acidic, and that is why it causes acid rain. So we have four types of oxides. Take note of this. Okay. Next, let's look at amphoteric. Like I told you before, amphoteric means something that can react with an acid and a base at the same time. Um, so amphoteric oxides are metallic oxides that show both basic and acidic properties. So what it means is that they can react with acids and bases. And we remember amphoteric oxides with SLAT. Can you see what I'm pointing at? SLAT, zinc, lead, aluminum, and tin. So oxides of zinc, lead, aluminum, and tin are amphoteric. SLAT, don't forget SLAT. Okay, so all these oxides are mentioned here are all amphoteric. Amphoteric are metallic oxides. SLAT. So we use SLAT to remember amphoteric oxides. Don't forget. So that's first. And then we have basic oxides. So when you remove amphoteric oxides, the oxides of other metals like sodium oxide, magnesium oxide, barium oxide, iron 2 oxide, they are all basic. Don't forget, amphoteric are also metallic oxides, but they react with both acid and bases. And we remember them by SLAT. Okay, Z stands for zinc, L stands for lead, A stands for aluminium, and T stands for tin. So oxides of other metals like copper, magnesium, barium, those ones are basic oxides. They are called basic oxides because they react with acids. Of course, they don't react with alkali. And then we have acidic oxides. Acidic oxides are oxides of non-metals. Non-metals are at the right-hand side of your periodic table. I mean, group 4, group 5, group 6, group 7. Your right-hand side, check your periodic table so that you understand what I'm saying. So acidic oxides are oxides of non-metals. Non-metal. All these ones you are seeing here are all acidic oxides. And the acidic oxides are not quite nice because some of them cause acid rain like SO2, NO2, SO3. These acidic oxides, they dissolve in rainwater in the atmosphere to form acid rain if they are present in a very large concentration. And then acid rain has a lot of consequences, like it decreases crop yield, crop, and then it corrodes some artwork, especially those artworks that are made up of limestone. So the acid will react with the limestone in the artwork, and the quality of the artwork will begin to depreciate. So these ones are acidic oxides. Next, we have neutral oxides. Neutral oxides are also non-metallic oxides, but they are monoxides. Mono means one. So if you check all these oxides, they are all oxides of non-metal, but each one contains one oxygen, one, that is monoxide. So what it means that CO2 is an acidic oxide, but CO is a neutral oxide. You get it? So NO2 is acidic, but NO is neutral. So we need to know that. Okay? So please take note of that. Both acidic and neutral oxides are oxides of non-metals, but neutral oxides are monoxides of non-metal. Monoxide means one oxygen per molecule. So if you see this NO has one oxygen, N2O has one oxygen, CO has one oxygen, H2O, which is your water that you take. So you see, water is a neutral oxide. It's not acidic, it's not basic. So, what do you think is N2O5? What type of oxide do you think is N2O5? That is nitrogen 5 oxide. Can you tell me? Nitrogen 5 oxide, N2O5. Well, it is acidic oxide. Why? Because nitrogen is a non-metal and it has more than one oxygen atoms. So that is nitrogen, that is acidic oxide. What do you think is, what type of oxide is chromium 3 oxide? Chromium. Chromium is Cr. That is basic because chromium is a metal and there is not one of those lats. So chromium 3 oxide is a basic oxide because chromium is a metal. So that's how you know it, okay? And this part is also very important point. An amphoteric oxide will react with both acids and bases. A basic oxide will react with only the acids. A basic oxide does not react with alkali. An acidic oxide reacts with alkalis but does not react with acids because they are acidic. Acids don't react with acids in most cases anyway. But in advanced chemistry, there are some situations where an acid will react with an acid. Neutral means not acidic, not basic. So a neutral oxide does not react with both acids and alkalis. So we need to know this. This is very important. This is very important. In fact, the task I'm going to send to you after watching this video will include this, and I expect you to do it very well, okay? So make sure you go through this. Amphoteric will react with both acids and bases. Basic oxides will react with acids, but they will not react with alkalis. Alkalis are soluble bases like potassium hydroxide and sodium hydroxide. Those are alkalis. Next, so in chemistry or IGCSE chemistry, there's what we call liming. Liming, what is that? Liming is a process that involves reduction of soil acidity. Soil, you know, we do agricultural practice, we do farming. You will discover that most crops don't grow well in acidic soil. So we need to reduce soil acidity. And that process is called liming. That is the name in soil chemistry. So we use powdered calcium oxide or powdered calcium carbonate for the process. Okay, but listen carefully. Listen carefully. Powdered calcium carbonate is more effective. The reason is because even if you add excess of this, it is insoluble. Okay, which means it will not cause the soil to be basic or alkaline. I repeat, yes, we use powdered calcium oxide and powdered calcium carbonate for liming purposes, but this one I'm pointing at is more effective. The reason is because this is insoluble in water. So even if you add excess of calcium carbonate onto the soil, it will neutralize the acid, but it will not cause the soil to be more alkaline or to be more basic. But this one will dissolve in soil, it will dissolve in water. If you have excess of this, it will make the soil to become alkaline, which is also not good. So you should know this. You should know what is liming. We also use this process to treat acidic industrial waste. Acidic industrial waste. We use this process to treat acidic industrial waste. Okay, so yeah, look at what I just explained. Okay, liming continued here. So calcium carbonate is preferred. This is very important. Calcium carbonate is preferred to calcium oxide because this one I'm pointing at is insoluble in water. So excess of it will not cause the soil to become alkaline. Very important IGCSE question. Unlike calcium oxide. And lime is also used to treat acidic industrial waste. This slide is very important. Please make sure you review this, especially this point. Okay, so that is all we have about oxide. So look at this activity, classify each oxide as acidic, basic, amphoteric, or neutral, each one. Please, you can pause the video and answer the question. Okay, if you are done, next one, the first question is basic. Why? Because calcium is a metal, so and it's not one of those lats. So the first one is basic oxide. The second one is acidic because chlorine is a non-metal. The third one is amphoteric because tin is one of those lats. Okay, and tin is a metal. So why can't we call this number three? Why can't we call it neutral oxide? It is not neutral oxide even though it has one oxygen. The reason is because tin, Sn, is not a non-metal. Remember that neutral oxides are oxides of non-metals, not metals, please, non-metals. So if I remove this Sn and put N, it becomes a neutral oxide. Okay. Number four is acidic oxide. Number four is acidic oxide because nitrogen is a non-metal and this is more than one. So it is acidic oxide. And number five is basic oxide because strontium is a metal. Okay. So thank you for your time. I'm going to send you some questions on oxide, specifically IGCSE questions on oxide, so that I will know if you really understood my lesson. Bye.